back. This is part 2. This is 5-4. You're solving the compound inequalities. Number 6, you're solving each of these inequalities. Here in the second part, I'm going to cover question D, E, and F. Notice the top part from part 1 were all and. D, E, and F are all or problems. Okay, so if you check your notes to do the or problems, it is very easy, as you just treat them as 2 different problems. Okay, so let's do it one at a time. So here's the first one on the left. All right, let me just give you room, okay, all right, to just see it better. All right, so we have m plus 6. It is greater than 14, so all we have to do is subtract 6 to both sides, leaving you with just an m greater than 4. I think what, 8? Okay, and then here, let's draw the line down. We have a plus 7, so we're going to subtract 7 to both sides. This cancels. Oh, I forgot to show this cancellation here. I'm sorry. Leaving you with just an m on the left-hand side here. 9 minus 7, which is 2. Bring down that inequality symbol. Make sure you bring down this or here as well. So your answers are this. M is greater than 8, or M is less than or equal to 2. Let's look at E here. It is an or, so we can treat them as 2 separate problems here. Right? So the first one, it is a m plus 3. It is greater than 6. So all we have to do here is subtract 3 to both sides. Subtract 3 to both sides. This cancels, just leaving you with an x. 6 minus 3 is 3. Bring down that inequality. Let's draw that bar down here. This 5x, the 5 is attached via multiplication, so we divide by 5 to both sides. This cancels, leaving you with just an x here. 5 over 5 just becomes the number 1. Because we divided by just a positive number, that inequality remains the same. And it is an or problem, so we just have to write the word or. So your solutions are x is greater than 3 or x is less than 1. Let's look at F now. This is an or problem again, so we can just treat it as 2 separate problems. The first one, let's draw the line down so we can see the left side from the right hand side. We see a 4 here, so that is the most outward thing, so let's get rid of it here. So we're going to subtract 4 to both sides. 4 minus 4 does cancel. What's left over is a negative 3x. 28 minus 4 becomes negative 24. This inequalities remains the same. Please understand this is attached via multiplication, so you're going to divide by negative 3 to both sides. When you divide by negative 3 to both sides, negative 3 over negative 3 does cancel, leaving you with just an x. The 24 divided by the negative 3, it is, I think, 8. Yes, it is 8. Okay, negative 8 here because of it's a positive divide by negative, so it's a negative number here. Right? Because we divide by a negative number, this inequality does flip. Okay, it was from a greater than, it becomes a less than. All right, let's do the second problem. Draw the line down here. All right, so the minus 10 is the outwardmost thing, so let's add 10 to both sides. This does cancel, leaving you with just a negative 7x. Negative 24 plus 10 becomes negative 12. Bring down that inequality symbol. This is attached via multiplication, so let's divide by negative 7 to both sides. Negative 7 divided by negative 7 does cancel, leaving you with just a letter x. The negative 12 over negative 7, well, you can't really do that, right? It's already improper, so it's just 12 over 7. The negative over negative does cancel, leaving you with a positive answer. Okay, the fact that you divide by negative, the inequality here does switch. All right, and there you go. And make sure you put the word or here, as that is the answer. So your answer is x is less than negative 8 or x is greater than 12 over 7. Fractions are perfectly fine. Okay, so there you go. These are all your answers. And for the work, for number 6, when we solve the compound inequalities, the top 3 were and problems, and the bottom 3 here were or problems.